Yes, hello Munindra. Welcome on YourPedia platform and let's start your thermodynamics snack for your final DRDO interview. So Munindra,
Yes,
what
sir.
is thermodynamics?
Thermodynamics. So generally in thermodynamics, we are studying about the energy transaction from one body to another, or we are just studying about the energy transfer here. Hmm. Yes, sir.
So that only you know about thermodynamics.
Yes, sir.
Hmm. What do you understand by thermodynamic
Sorry.
equilibrium?
In the thermodynamic equilibrium, we are talking about the mechanical equilibrium and chemical equilibrium and that temperature, thermal equilibrium in the thermodynamic. In the mechanical equilibrium, there is body in equilibrium with a force. All the forces are in equilibrium. Second, in chemical composition will be should be in equilibrium, and the temperature should be in the at the same temperature. You can say it's a thermal equilibrium. There are
So
three.
how you will check whether the system is in that equilibrium or not?
Sir, as we're talking about the mechanical equilibrium, there are all the forces and moments should be in equilibrium first in mechanical, and for the chemical equilibrium, the chemical composition should be in equilibrium. There is not getting any reaction from one substance to another. There is no chemical reaction, and in the thermal equilibrium there is a temperature. There is a all the substance have the same temperature. Yes, sir. It's a thermal equilibrium. So yes, sir.
Munindra, if I will give you a kind of a rigid tank,
Okay.
and let's
Yes, sir.
consider some kind of wet steam in that rigid container.
Okay, sir.
And now suppose if you start heating that content which is there in the rigid container, okay.
Mm-hmm.
So what you feel? The level of the water, the level of the liquid in the container is going to drop or it will rise, and why? Let me again repeat
Sir.
the question, Moninder. There is
Yes,
a
sir.
rigid container. There is a rigid
Yes,
container
sir.
which is containing some wet steam. Okay. What
Okay.
is the exact
Okay.
quality that I'm not giving you at this moment? You can ask me later on. So quality I'm not giving, but
Mm-hmm.
the wet steam is there. And now what we are doing, we are heating the content. We are heating the steam, the wet mixture.
Mm-hmm.
And what I'm asking you, the what you feel, the level of the water in the container is going to decrease or increase? How you will check?
So there is a rigid container. If we increase the temperature, then there is a wet steam. So after the gases vapor will increases. So actually, I don't know, sir, about it's the confirmation, but it's I just say that if there is some water content there by
Achha,
the
okay, just draw the PV diagram. Okay. And locate the initial condition of the content. Fine, Moninder?
yes, sir. Yes, sir.
Draw PV diagram, locate the initial condition and try to locate the final condition also.
Okay, sir. 1 second.
Hmm.
So volume should be constant, but pressure is increases continuously with temperature.
Obviously, yes, pressure will
Yes,
increase,
sir.
volume will remain constant.
Yes,
Yes,
sir. Yes, sir. So
go to the question. Yes, Maninder, done.
sir,
Yes, you want any further more input?
Yes, sir.
Just show me the process, the initial and final state, which you have drawn on the PV diagram. Remember? Just put it in front of the camera.
टीएस डायग्राम्स का कुछ इस तरीके से बनेगा.
Why you are drawing TS diagram? Why not PV diagram?
Yes, sir.
I actually I have given you the hint. Draw PV diagram and locate the initial condition.
प्रेशर बढ़ेगा एंड वॉल्यूम कांस्टेंट रहेगा, टेम्परेचर भी
We don't know
बढ़ेगा.
the PV diagram. How we can draw PV diagram? Pressure volume diagram.
There is a straight line or volume constant at sorry, there is no work, sir. So
Why actually, it's fine, it will be a vertical line.
yeah.
But why you are not showing that process on between the phase change curve? Fine.
Yes, sir.
Murinder, this kind of line we normally show for gas, a
Yes, sir.
superlated mixture.
Yes, sir.
But what condition I have given you? The wet stream, wet region. So initially we are in wet region. Yes or no? So why
Yes,
you have
sir.
not drawn the phase change curve? Just draw the phase change curve on PV diagram. The saturated liquid line, saturated vapor line.
Yes, sir. Okay. Okay, sir. 1 second. सर ये तो पीवी ग्राफ कुछ इस टाइप से बनता है, बट इसमें ये वाला रीजन जो आएगा, ये वाला, ये लिक्विड प्लस वेपर, ये वेट रीजन रहेगा. यस सर. एंड यहाँ पर इस रीजन में सर वो मतलब PV इक्वल टू एनआरटी ना लग के सर इसमें तो जनरल वेट रीजन में तो डिफरेंट वो यूज होगा.
If you are taking a vertical line in that wet region, what you feel dryness fraction is going to increase or decrease from initial condition 1 to final condition 2?
So dryness fraction increases.
Increases.
It's in a wet region. If we're talking about
the dryness fraction is only going to increase if the initial volume is greater than critical volume. Why? Yes, fine. So you are taking this line on the left, right.
Yes, sir.
What if the given volume, the initial volume at point 1 is less than critical volume? Then also the dryness fraction will increase or it will decrease? The point 1 which you have taken, Muninder, at
Yes,
point
sir.
1 you are taking, at point 1 you are taking the volume greater than critical volume.
Yes, sir.
Okay. So what I am asking you, if the volume is given volume at point 1 is less than critical volume, then also the dryness fraction will increase or it will decrease?
No, sir. On that case, dryness fraction decreases.
So how you can conclude the dryness fraction will increase? Okay, just tell me one thing, Muninder, if the dryness fraction is increasing, for example, let's consider a case.
Okay.
The tank which we have considered, in that tank, the specific volume at initial stage is greater than critical volume. Okay. Now we are heating and the dryness fraction is increasing. Okay. So with the increase in dryness fraction, the level of water, the level of liquid in the container is going to drop or it will rise.
So in the if dryness fraction increases, then liquid content decreases and vapor content decreases, sir.
As in the idea, Muninder, got
yes.
the idea? The question which I asked you, how to approach, how to answer that?
Sir, in the turbine, as in the या फिर we can talk about compressor in the refrigeration also, or in the turbine when we increases the dryness as we going to the vapor side, we have to go from liquid to vapor. Then vapor content increases and the dryness fraction is also increases in that case.
Okay, Maninder, let me ask you one more question.
Is it
Maninder,
right,
what do you
sir?
understand by principle of increase in entropy of universe?
Sorry.
What do you understand by principle of increase in entropy of universe?
Principle of increase in entropy. Sir, it is always increases cyclic integral of dq by t is less than or equal to 0, whether ds equal to ds of universe equal to dq by t plus s generation. तो यहाँ पे generation के कारण इसका जो entropy होगा वो continuously sir increases, it will increases continuously for the universe. And the degradation of energy in the entropy, but the quality decreases, but the entropy is always increases for the universe. If we talk about
Maninder, what is entropy? What is the significance of entropy in thermodynamics?
entropy, 1 second, sir. So it is the entropy is defined as the randomness of the energy, randomness of the molecules within the substance. Or when we talk about for the entropy generation, it is a degradation of energy, and entropy is a point function.
Mm-hmm.
And significant as we we are talking about that for the higher temperature to lower temperature,
Maninder,
the yes sir.
according to second law of thermodynamics, a real process is always going to execute in the direction of degradation of energy.
Yes
The
sir.
quality of energy is always degrade.
Yes sir.
The quality
Okay.
of work is more than quality of heat.
Yes sir, it's a high grade energy, work is a
Yes.
high.
So
Yes sir.
when we are converting heat energy, like in a IC
Hmm.
engine, in a IC engine or
Okay.
a heat engine, what we do, we carry out the combustion of fuel. So the chemical energy of the fuel we convert it to the heat energy, and then we convert heat energy into some shaft work or mechanical work.
Yes sir.
So how you can say that that process is in the direction of degradation of energy? Because it's looking like conversion of
Sir,
heat into
when
work.
we no, sir. Actually, as you said that in the IC engine, there is a we can consume a lot of low grade energy as a heat energy. Sorry, the chemical energy. Chemical energy converted to the heat energy, then by which we got the work. Here, a lot of heat energies means. Uh, Sir, actually, I cannot explain it. It's a
Yeah,
chemical combustion. It's also here, no, sir.
fine. Just take an example of steam turbine.
Sorry, steam turbine.
Yes, just take an example of a steam turbine. Forget about combustion. So in steam turbine also what we do, we convert the thermal energy, the heat energy into the
Uh,
mechanical work. So that is also a real process.
hmm.
So in that also we are converting heat into work.
Sir, there is a means a lot of heat energy will be consumed, and we got the less amount of work. And there is some heat energy which goes for the it's the unavailable energy. Sorry, क्या बोलते हैं, इंटरनल एनर्जी में जाता है कुछ एनर्जी सर इसका, जो कि हीट एनर्जी का सारा वर्क में कन्वर्ट नहीं हो पाता है बिकॉज हीट इज अ लो एनर्जी, लो ग्रेड एनर्जी.
Okay. Murinder, mixing is a irreversible process.
Mixing of irreversible process. Yes, sir.
So where are the irreversibilities in mixing process? Why it is considered as a highly irreversible process?
Actually, I don't remember the full concept of
So,
irreversibility. I
Bhumika,
remember the.
my last question to you. What is
Yes, sir.
your understanding related to second law of thermodynamics? Just tell me something, from something from the understanding you acquired, you got from this subject. Okay.
Mm.
So tell me about second law of thermodynamics, Bhupender.
Uh, okay. Can I take the Kelvin Planck and Clausius statement? Can I say?
Okay,
Sir.
go ahead. Go ahead.
Okay, the Kelvin Planck statement is that it is impossible to develop a device by which we can 1 second, sir. Yes, sir. It is impossible to develop a device by which we can convert the all of heat energy to all of work within a single reservoir. And the Clausius statement, it is impossible to develop a cycle by which we can transfer of heat from the low grade temperature to high grade temperature without any work input. Yes, sir. It's a Kelvin and Clausius statement.
So, Muninder, I think now I can provide you the feedback.
Yes, sir. Yes.
Yeah. So, Muninder, I asked you some of the very basic direct questions actually, okay, from this subject,
Mm.
thermodynamics. I started with what is thermodynamics?
Yes, sir.
What do you understand by thermodynamic equilibrium? Okay. So, you mentioned only one line actually for thermodynamics. You
Yes,
mentioned
sir.
so many things about thermodynamics. You can highlight about the important significance of first law of thermodynamics. These are, the understanding which I acquired through this subject is what key,
Mm.
sir. We cannot create energy. The creation of energy is impossible. The destruction of energy is impossible. Only what we can do, we can carry out the energy conversion. Okay. Then second thing is what, sir. Through this subject, we get idea the complete conversion of heat into work is impossible. 100% efficiency is impossible. Okay. A real process is always going to take place in the direction of degradation of energy. All real processes will take place in the direction of increase in
Degrade.
entropy of universe. Okay, so these are
Okay, sir.
some of the very important conclusions you can highlight about what is thermodynamics and what you studied in that subject. Moninder, when we are converting heat into work, okay,
Yes,
so
sir.
the
Yes.
available energy which is there in the heat is much
Mm.
higher as compared to the work which we are getting. The available energy of the work is what? Whatever work we are getting, that entire is available energy because work is
Yes,
a
sir.
active energy.
Yes, sir. But
So when we are converting heat into work, the available energy which is there in the heat input to a particular system
mm.
is much higher.
Yes, sir.
So when we are getting the work, means we are losing some part of the available energy. Are you
Mm.
getting, Maninder? Although we are
Yes, sir.
converting heat into work, but when we are converting heat into work, we are losing some quality of the energy. We are losing some of the available energy.
Yes, sir.
Maninder. So that's
Yes,
why
sir.
that is known as degradation. Because what? Why it is known as degradation? Because we are losing the work potential. In all
Work.
real processes, we lose some work potential. Loss of available energy is known as what? Increase in unavailable energy, and that is nothing but irreversibility. So whatever work potential we lose in a particular process, real
Yes,
process,
sir.
that is known as irreversibility, and that is known as degradation. What is the idea, Maninder?
Yes, sir. Yes, sir.
Clear why the real process, we say takes place in the direction of degradation, and what do you mean by degradation? Is it clear to you?
Yes, sir. Degradation of energy.
Fine. That is also known as exergy destruction. Okay.
Yes, sir.
I asked you one question in the beginning, like you are having a rigid container. For DRDO or
Mm-hmm.
ISRO kind of organization, you need to, be ready with some pen, paper. You need to draw the PV cycle, PV diagram, and then you need to conclude. Don't reach to any conclusion directly. Maninder. Think of
Okay,
the
sir.
processes. So when we are heating, pressure is going to increase. volume is going to remain constant. So means we are considering two things: pressure, volume, pressure, volume. One thing we know, the volume is constant. Second thing we know, pressure is going to increase. So then you can draw, you can take, you can think of the initial condition, wet steam. So you will draw the saturated curve, you will locate the initial condition, you will draw the vertical line, and then definitely they will provide you the hint. The initial volume is greater than critical volume or less than that. Are you getting, Murinder?
Yes, sir. Yes, sir. Yes,
But you
sir.
have even not tried actually in the beginning. Without touching any pen paper, without drawing PV cycle, you know started concluding about that process. Are you getting? That is not the right approach actually. You know to think,
Yeah.
you have to follow the step by step approach, and then only you know to try to make some conclusion. If you are following that process, Murinder, whether
Yes,
your answer
sir.
is right or wrong, they will consider you. They will consider you. They will give you the advantage. If you are following
Okay.
the particular step by step approach, means you are applying your mind. You are showing your creativity actually, and that they want. They don't want some direct answers. Are you getting?
Answer. Yes, sir. Yes, sir.
What they want, how a student is approaching a particular question. Okay, is it clear,
Yes,
Murinder?
sir. Yes, sir.
Chalo. So then at last I ask you what is your understanding related to second law of thermodynamics. Then also very typical Kelvin Planck's closest statement you have highlighted. You've not even talked about the
Yes.
entropy generation, exergy destruction. Okay, 100% efficiency, all those things. There are so many things you can highlight about second law of thermodynamics other than Kelvin Planck's and closest statement. थोड़ा सा आप nervous भी थे, slightly nervous you are in that discussion, maybe due to your first smoke, first
Yes.
snap. If you practice more and more, Moninder, I feel you will get the idea, you will get the clarity
Okay.
how to recall actually all those things if someone is asking
Okay.
those kind of questions. Fine, Moninder.
Okay, sir. Okay, sir. Sir,
Okay, good luck.
one more thing I want to ask you. Sir, there is a lot of videos in this as I purchased the course. There are a lot of videos, but sir, I didn't understand what is important for me. And
Moninder,
there,
you need to only watch the snaps or mocks related to DRDO.
okay, sir.
Last year also lots of students joined us, and similarly there are so many mock snap session available, so some of the videos you can start watching. Okay, but that is
Okay,
a
sir.
one part
Okay, sir.
only. Suppose for example you want to be a good cricketer, so yes,
Okay.
obviously initially you need to watch some of the cricket match so that you will be able to you will get the idea how to play the cricket. Okay, and you will be
Yes, sir.
familiar with the terminology related to that. Second, what you need to do, you need to you need to do some net practice, and those are these snaps are going to provide you that kind of net practice. And finally, obviously,
Okay.
you need to play some game.
Okay, sir. Okay, sir.
Finally, are you getting, Murinder? So if
Yes, sir.
students are
Yes,
only
sir.
watching cricket match, just by watching cricket match you are not going to become a good cricketer. Okay, so that is a one part. That is a one part.
Okay,
It's
sir.
good to watch those like snap sessions or full mocks. Watch them and then go for
Okay,
more
sir.
and more snaps. Fine, Murinder.
Yes, sir. Yes, sir. Okay, sir.
Okay, good, Moninder,
Okay,
and
sir.
good luck. Best of luck for your final
Thank you,
interview.
sir. Okay, sir. Thank you, sir.